It's a little video about air suspension, valve blocks mainly. Applies to Range Rover Classics and also P38. Enjoy. Right, so I've got it all out of the case. On the Classic, the case looks like that. On the P38, it's a plastic box that sits under the bonnet. Let's turn the blower off. And we've got here the valve block. Ignore these pipes in the front here, they're just to help me do the diagnostics. We've got the dryer, we've got the pump. I tried to set this test rig up using an original ECU and loom, and I can't figure out the electrics, and I kind of ran out of time. I will figure it out because there's one giant big connector that goes into a loom, and it picks up signals from a number of different things, including things like the handbrake sensor, the alternator to confirm that the engine's running, etc, etc, etc. And while I haven't been asked to do the diagnostics to work out if I can split that up. Now, quick desk tidy up here, because what I'll do is I'll show you the problems we're having here. So this pump, this valve block have come out of a customer's car. First and foremost, the pump was not responding to any of the usual signals. He rebuilt it and it still doesn't respond to the usual signals. So what you do with these, take my two connectors off here, we go to the diode tester, the continuity tester on your multimeter, and we bridge between the black wire and the orange wire. So you've got a nice helpful little stub in the middle here, and if you've got no circuit, it's an open circuit, then the resistor has failed, the thermal resistor has failed. And I can demonstrate that by coming to another pump here. We'll do exactly the same thing. No witchcraft, no wizardry. Black wire and orange wire. And you can see that's a closed circuit. So the thermal resistor in that one is good. Right, so what have I got here and what's going on? Well, I've got this rather neat box of tricks here, which I bought with a load of air suspension parts at a very good price off one of my followers. Name inserted here. Forgot your name, sorry, I should have researched it before I started the video. And thoroughly nice chap. Made this box, which you give a power supply to, and then it's got a connector, which has been robbed off the loom of an EAS car. If it comes apart, it's going to come apart. Come on, you fucker. And that then plugs straight into the valve block. That was probably one too many swear words. So there's nothing particularly fancy about this box. All it does is it bridges the various circuits so that I can, on this, give it power and then say whether I'm raising the airbag or lowering the airbag. It's very primitive, but it is very effective at what it does. And then I've got the 4 airbags here. So position 1, position 2, position 3, position 4. And those airbags are listed in the ROM, which I've just tidied away over here. There's a printout of the workshop manual. And in here we have got, okay, so number 1 is the red terminal. Can we see if we can untangle this so we can get it a bit nearer? Right, let's untangle it and got it a little bit more in so we can see everything that's going on here. So 1 is the back left, and it's got a red port, and it's actually even labelled on the front of the valve block as port 1, back left. And then port number 2 is the blue terminal, which is directly below it, which is the back right. And then we've got front left, which is port 3, yellow, that one down there, and port 4, which is the green one, which is up here on the valve block, and that then goes to the front right. The other things we've got So these valve blocks, there's a lot of ports on there, and it might seem confusing, but it isn't really. The way it's laid out, let's come in real close. So we have got here, pump goes into the side of the valve block over here. There's a non-return valve in there. We've got the exhaust is port 9. Port 7 is the air out that goes to the dryer and then goes back into port 5. Okay. Port 5 then directly feeds port 6, which goes to the accumulator, the reservoir. And then we've got a series of solenoids which dictates then whether we need to have air taken past to or from each of the 4 corners, which is what these 4 pipes are on here. Now, I didn't destroy a set of 4 pipes. One of these, probably that box down there, someone had just hacked the pipes off when they'd taken the box off it. And again, got that very, very, very cheap. Thank you, sir. Same chap who did this. So it doesn't matter. He probably didn't drop these pipes. He just had a load of spares. So I've used these pipes now to give me a rough idea about what the valve block is doing. Now, having done that, let's go back upright. And I can connect up the electrics here. So I'm just using a 12-volt battery. There's nothing complicated about this. I have got here the electrics for my box of tricks, and I have got then the electric wires which are going to go to my pump. So I'm just going to hotwire the pump. The pump will work if you just hotwire it, but it won't work if you connect it up to the ECU if the thermal resistor has blown. I haven't worked out a way of getting past that yet, but if the thermal resistor's blown, you probably want to concentrate on that rather than messing around with it. In fact, I'll switch it on the earth. So let me just connect these 2 up again. I'm looking like a bin man because it's blimmin' cold. Right, okay, so now we can already see. Port 11, by the way, is this little chappy up here, which is an air inlet. It seems to, this process seems to work regardless. So I can connect up the pump. And here, on the accumulator port, I can feel air coming out of that at a fair pace. Now, we weren't getting that when this system was first set up. So we are now. So the next thing I do is I say, right, I want to raise the suspension. And I want to go to port 1, which is red, this one here. I'll block up that. Can you hear it? So we know that was working. Okay. The reason I have to block off this port down here is because it will not start to fill the bags up until the reservoir has reached a minimum operating pressure. Okay, so I can just simulate air going through the valve block by flicking the switches here, just by doing that. So at the moment, if I was to, I can't put a Schrader valve in it because it will just, let's go back to 1. You can hear what happens here. If I have none of the bags open and close this, that's starting to build up some pressure in there, yeah? Which I don't want to do. So I'm going to open up port 1. Nothing. Sorry, air. Nothing. 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 Right, so we'll go to port 2. Air. Nothing. 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 Port 3, which is yellow. Air. And port 4, which is green, working beautifully. And then I can flick all 4 of them on, and I'm getting air out of all 4 of those now. A reasonable amount of air. Enough air that within a couple of minutes we're going to start filling those bags up. So that's the first part of the test. Turn the pump off now, because there's no point having the pump for the second part of this test. Now, the second part of this test is I want to test whether the solenoid is going to allow me to let the air come back out again. Now, when you deflate a bag, if my logic is correct on this, because we're in deflate mode now, okay, not raise mode, we're in deflate mode, okay, what should then happen is, because that's now solenoid 6, 5 and 6 dictates whether we're deflating or inflating. So solenoid 6 is now opened, which now means that when I deflate, blow air into here, it should come out of that port there. Okay, but I should be able to breathe through it. So with none of these solenoids open, if I were to get my face around one of these pipes, can't do anything at all. Now, if I flick switch 4 on deflate, I can blow through it. Nothing. I can blow through it. Right, so let's check port 3. I can blow through it. Port 2. I can blow through it. And port 1. I can blow through it. So, it would strike me that all of the solenoids in here are behaving as they should. As far as I can see, the valve block is working nicely. I would like to have tested it using the ECU, because then I could test all of the functions around the thermal resistor and so forth. But I can't, so I shan't. I think that's about it really. I'm kind of inclined to lob that valve block back on again. I think the reason it wasn't working is possibly a mild overuse of my nemesis thread lock on this valve block here. In fact, certainly the plunger inside the solenoid had quite a bit of it around the plunger. In fact, let's take that one apart on this valve block here, and I'll show you what it looks like inside. Right, so this is the electrical part of the solenoid. Lift that chappy off there, and then underneath we've got the valve. That's your solenoid, that's your valve, and inside there is a plunger. It gets drawn up by the magnetic draw of the solenoid. And next we find a flat blade screwdriver and we take the valve off the top. So underneath this, now I've got a couple of holes in here in the top of the top of the valve block, and the idea is it's a plunger in there that lifts up and allows air to go from here, the inlet, to there, the outlet, or whichever way round it actually is. Now, if I then, because we can further strip the valve down, undo these two chappies here, which are really tight. Not tight. And on the inside of this, to be a little bit careful taking this apart, take the cover off. There goes the cover. Okay, and underneath we've got the plunger. Now, there's the body, the lower body. There's your solenoid with a little spring in the end of it. So when I give power, it sucks that in and relieves the seal around that little centre hole in the middle there, because that gets sucked in. And then as soon as it lifts up from that centre hole, you can see the holes either side of it, hopefully. That then allows air to bypass the solenoid. So it is a really, really, really simple setup. Each of these solenoids, by the way, they are different solenoids for different functions. So don't just rip them all off. Or so different valves, I should say, for different functions. Don't just rip them all off and expect the damn thing to work. Make sure you put them back from whence they come. So you'll see this one on the front here says 4.0. 4.0, 4.0, 2.0, 2.0, 2.0, 2.0, and the one on the end here has got a really, really tiny valve underneath it. Ah, lovely tidy bench. You know what that means, don't you? Right, it's pumps. Right, okay. So I've been rattling through the pumps. Got two pumps from the customer. And in both cases, the thermal resistor has failed, but in one case it hasn't. Allow me to elaborate. So just to reiterate, here is a nice, good pump. We've got the connector on the back here, we've got 3 wires going to the back of it, and we want to test the resistance, continuity from the black wire to the orange wire. So if I put the multimeter on that, and then on the orange wire you can hear the multimeter beeping away. That's a good one. This one is a bad one. So again, do the same thing from the orange wire to the black one. We've got a open circuit. Now, as I have mentioned already, the actual thermal resistor, if I just take the loom off this, because I've been pulling this thing apart, the actual thermal resistor is this little bastard down here. It's an Airpax. It's an Airpax thermal resistor, and its part number is, so I wrote it down, it is an Airpax 67L for Lima 1250145. It's actually written on there as well. The red marking is from me, because I know it's fucked. Now, what you effectively want to do is the orange wire goes onto this terminal here. If I were to put continuity onto that terminal, and the plate is loose at the moment because I've drilled it out, on that terminal I get continuity. It's not the best continuity, but I'm getting continuity. There we are. Now if I then go to this terminal, I should also get continuity, and I'm not. Okay, that's interesting. And if I test between those two, that's fantastic. Now the black wire goes to this brush here. So if I test continuity from there to the far pin, I get continuity, and to the nearest pin I get nothing. So very clearly that little thermal resistor there has failed. Now to get these off, the orange wire, if it's not a soldered in one, have I got one that's soldered in? Yes, I have, right here. So there's 2 different styles here. There's one where the wire goes through the printed circuit board and solders on the other side. And these typically have fatter brushes as well, oblong brushes. We've also got one here with oblong brushes on it, where the wire just pushes into that clip there. So you just push it down and into there, and it traps itself in there, a little bit like one of those blue Scotch block connectors. And then we've got a really early type, I'm guessing, where the brushes are square and not oblong. And that also has the push-in connector. So, this one here, the one with the blown resistor, which I painted red, if you were to drill the tops of the rivets off, 4 rivets to hold it on, you can then take this plate out, okay, and work on it. The problem I've got at the moment is the thermal resistor is on a 9-week, yes, 9-week lead time. Obviously there's another big batch of them coming in from China. It's also trying to find a supplier that will actually do me a couple of units rather than 500. I don't want 500 units, I want a unit. And a unit works out about £7 to £10. I've seen them up as high as £16, but again they're not available for 9 weeks, so I might as well wait the 9 weeks and spend the £6 or £7. Now, this one here, so this is the one that came off the customer's pump that was in the car. If I check the continuity on this one, between the black wire and the orange wire, I'm getting nothing. So then I think, right, okay, well let's go down and just see if we can check the continuity onto the resistor, see if the wire's broken, for instance. So we then check the continuity from the wire to the first pin. Oh, we get continuity. And to the second pin. Oh, we get continuity. Well, that means the resistor is actually working. The resistor is a closed circuit. Okay, let's check continuity from where the black wire goes in to the furthest pin. Ah, well, see, there's your problem. There's a breakdown in the circuit between the black wire onto that brush and the back of this circuit. Now, when I look at the back of the circuit board, it looks like it's just a short track that goes from there to that pin. Now, I could probably fix that just by soldering a short piece of wire in between the edge of the brush plate and that pin, and that will give me the continuity I need on this one, so I can get that one working again. But goes to show you that it's not necessarily the thermal resistor, because when I test across the pins on this one, I'm getting continuity. And the only way I'm not getting continuity is when I go back to Earth. So, I think realistically, if I was to find a way of running a wire down to that post there, which is exactly what I'm going to do, I can reinstate this and the customer's original pump. That from the customer's spare pump is dead, needs another thermal resistor and a 6-week lead time. And then, this being the customer's pump here, I can put this back together again and we can be in a working pump scenario, which would be beautiful. Okay, so that's pretty much about it really for these things. When you take the brushes out, by the way, that's obviously the orange wire there. In fact, that orange wire there is looking a little bit, no it's not, it's just dirty, grubby. But I think that makes sense, doesn't it? Does it make sense? I hope it makes sense. So, I am going to do that, and I don't even really need to take or drill the rivets to take the plate off the back plate. Now, if you were going to take the plate off the back plate, what have I done with it? Put it over here. What you realistically need to do is to drill into these posts, tap them, and put a couple of screws in there so you can hold the damn thing down. They can be self-tappers or they can be threaded screws, machine screws. It makes no odds. Just make sure they go down properly. Just before the end credits, give me a thumbs up if you liked that. Give me a thumbs down if you didn't. Mind you, you've got all the way to the end of it, so you probably would have given me a thumbs down by now anyway. Comments down below. All of these things do help to promote the work that I do and promote to YouTube for your benefit. If you want to contact me, churchhouseclassics, it's all one word, @gmail.com. And if you want to support the channel, then there's a PayPal me link scrolling down here. Both my email and the PayPal me link are in the description below this video. And that's my car, still sitting here. I might have to change this feature once it gets back on the road. It'll embarrass me enough into getting this back on the road. Anyway, thank you very much for watching.